Today we learn about the game theory. First we start with the introduction. Game theory is used for decision making under the conflicting situations where there are one or more opponents. That means conflicting situations means that are the courses of action, whatever the courses of action chosen by the people or the opponents, that is known as the player. Conflict means they have to strictly determine which course of actions to be taken. That time they are conflicting. A player may be an individual, a group of individuals, or an organization. So what are the players? We can see in the game that the players may be an individual may can play, a group of individual can play, or an organization can play. The models, for example, chess, poker, etc. are the chess is played by the individual of the two opponents, are the games which have the characteristic of a competition and we are played according to the definite rules. Definite rules, that means the strategies is the actually course of actions, but for the game there are some rules. That means that there is some assumptions or the guidelines that we have to follow when we are playing a game. That means strategy basically little bit different from the rules. Game theory provides solution to such games, assuming that each of the player wants to maximize his profit and minimize his loss. There is the two types of the players is there. One is try to maximize his profit and another is try to minimize his loss. The game theory was originated by J.V. Newman in the year 1928 and later it was developed by G.B. Tenjik. Game theory is the study of mathematical model. So what is the game theory? Game theory is the study of the mathematical model of conflict and cooperations between the intelligent relation discussion makers. Game theory is mainly used in economics, political science, and psychology, as well as in the logic in the computer science. Originally, it addressed the zero-sum game in which one person's gain result is loss for the other. That means one gains is equal to the other's loss. If we mathematically sum up, one is the positive, another is the negative value, but both value, magnitude value of both is the same. If we add up, we will get the zero. For the other participants, today, game theory applies to a wide range of the behavioral relations and is now an umbrella term for the science of the logical decision making in humans, animals, and the computers. So very much applicable in the decision making or in the gambling or win in the market, in the advertising market also. There is the competition is their goal. Consider a situation in which two boys A and B simultaneously draw either one or two balls which they have in their bags. It was so decided that if the number of the balls drawn by the B be the same as the number of the balls drawn by A, then the boy A wins and gets 1 rupee from B. Problem is that two player is there, player A and player B. Both have the bag, and in the bag they have the balls. If the balls drawn, both of them are the, it was decided if the number of the balls drawn by B be the same as the number of balls drawn by A. This is the one ball, this is the one ball. So both, when A drawn the one ball and player B also the drawn one ball, so 1-1 is matching. That means we have to pay 1 rupee to A. Suppose if A is drawn 2 ball and B is drawn 1 ball, this is the mismatch. That means A have to pay 1 rupee to B. In this case, 1 ball is drawn by A and 2 ball is drawn by B. That means 1 rupee have to pay to B by A. If the match, then A will get, that means B have to pay. If not match, then A have to pay to B. This is the pay off for the other problem. On the other hand, if the number be not same, then B wins and get 1 rupee from A. This situation is expected by the first table. The possible courses of action of the player B and A are shown respectively by the columns and the rows outside the table. These are the courses of action. That means this is the choice for the player B drawn the 1 ball and 2 ball. This is the course of actions, or we can call it the strategy for the player B. And for the player A, this is the course of action. Player A can choose 1 ball drawn or drawn the 2 ball. This is the courses of action, we can say. By the columns row outside the table. The positive entries in the table are the payments from B to A. If the positive entry is there, that means B have to pay that much value to A. If it is the negative value, then A have to pay that much magnitude of that to B. And the negative entries are the payments from A to B. Only the value, not with the sign. Consider again the situation in which the two boys A and B playing a game, they simultaneously and independently write one of the 3 numbers. That means 3 numbers is there, and from that 3 numbers they can select any one, and we try to find out the sum of the 2 numbers. If it is the even, then A wins and B pays to A an amount equal to the sum of the 2 numbers. If the sum be odd, then B wins and A pays to B an amount equal to the sum in the rupees. This situation expressed in the matrix. Suppose player A, and there is the 3 numbers. So course of actions, 1 is rupee 1, 2 is 2, and 3 is 3. Player B also the 3 course of action, 1 to 3, and value is 1 to 3. Suppose randomly if I choosing for the explaining this problem, suppose player A chooses the 2 and player B chooses the 3. Sum is the 5. This is the odd. When it is the sum is odd, that means player A have to pay that sum of the rupee to B. Sum of the rupee is 5. That means A have to pay to B, and that's why it is with the negative entry minus 5. Again, player A chooses the 2 and player B chooses 2, and we find out the sum is 4. That means B have to pay rupees 4 to A. So when A is selecting 2, it is unknown to the player B, and when it is player B is selecting the either 2 or 3, It is completely unknown to the player A. As soon as A is selected any number and B is selected any number, they can show each other, then we can get the sum of this number. Unless until the played by the player, that strategy is unknown to the opponent. In which the course of possible action taken by A and B are shown by rows and columns outside the table associated with A and B. I already explained respectively. For example, that is I already explained similar meaning associated with the other entries. This is I already explained that explanation whatever is here. Now some definitions is there related to the game theory, that basic terminology you can say and or the definitions. Unless until we learn the definition, we cannot move to the deep into the game theory. Player. Each participant in the game is called the player. A player may be individual or group of individuals or an organization. So any player can play individually, or he can form a group, or he can represent as an organization. Organizations can behave as a player in any competitive game. 2% and in-person game. If in the game, in the competitive game, if there is the 2% only, then it is called the 2% game. If it is the in-person is there in the competitive game, then it is called the in-person game. If the number of players is 2, it is known as the 2% game. On the other hand, if the number of the players is n, it is known as the in-person game. Zero sum or non-zero sum game. In a zero sum game, the sum of the points won equal to the sum of the points lost. Mane someone gains and opponents is lost is equal, and if we sum up this, one is positive, another is negative, you will get the zero. That's why it is called the zero sum game. That means one's gain and another loss is equal. That is one player wins and another player is lost. In the zero sum game, the sum of the points won equal to the sum of the points lost. That is one player wins at the expense of the others. To the contrary, if the sum of the gains or the loss is not equal to zero, it is either positive or negative, then it is known as a non-zero sum game. That means in a competitive game or in the competitive market, someone's gains and someone loss or someone gains is not equal, then it is called the non-zero sum game. It is, we can see in the advertising market when they are promote their product by using their advertisement, and their difference may be positive or negative. An example of non-zero sum game is the case of the two competing firms, each with a choice regarding its the advertising campaign. In such a situation, both the firms may gain or lose, though their gain or loss may not be equal by using their advertisement. That's why this type of the game is not non-zero sum game. 2% zero sum game, a game with the two players, whereas one where the gain of one player equals to the loss of the other is known as the 2% zero sum game. It is also called a rectangular game because their pair of matrix is in the rectangular form. The characteristic of such a game are only two players participate in these games, 2% zero sum game. That is the basic assumptions or the rules for their game. Only 2 players participate in the game. Each player has a finite number of strategies to use because we are handling here the finite game. We are not using here the infinite game. Each specific strategy result in a payoff matrix. That means what are the combination in the strategies payoff, that is the predefined and defined in the within the rectangular box, that is the payoff is defined. Total payoff to the 2 players at the end of the each play is 0. This because this is a zero sum game. Whatever the gain of ones is equal to the loss of the others, an opponent player. If we sum up, we will get the 0. That's why one's player gain at the end of the game and another player's at the end of the game loss are equal. Strategy. What is called the strategy? You already used these terms, course of actions of the strategy. Now we try to give the simple definition. It is predetermined rule by which the A player decides his course of action from his list of course of action during the game. Course of actions is available, and from the course of actions, player can predetermined rule from the can select that the course of actions, that course of actions is known as the strategy, pure strategy. And we learn next the mixed strategy. Pure strategy, it is the decision rule to always select a particular course of action when player is playing. Course of action is more than 1, 2, 3 or 4, but when the player stick to a particular course of action, then it is a pure strategy. It is decision rule to always select a particular course of action. It is usually represented by a number with which the course of actions associate. The course of actions, if we listed as 1, 2, 3, 4 like that. So if any player stick to a course of actions, the fourth course of actions, stick to that, then it is known as the pure strategy. Mixed strategy. That means when the players switch over from one strategy to another strategy, means one course of actions to the another course of action, that is known as the mixed strategy. It is not stick to a particular course of action. Time to time, to maximize his gain for the maximizing player, he is changing his course of action from 1 to 3, 3 to 5, 5 to 6, or back to the 1, again 2. And for the player B, minimizing player, it is choosing the course of action first 2, then 1, then 3, and 4, and it is changing. And maybe the combination of 1 and 2 or 3 for the player A and B also to maximize the gain and try to minimize his loss. That combination is known as the mixed strategy. Now, in the exact definition, mathematically, a mixed strategy of a player with m possible courses of action. For the player A have the m courses of action is a set S of m set S of the non-negative numbers whose sum is unity. That means a player chooses course of actions with the probability. That means it is choosing the course of actions with the probability. Suppose for the player A, there is course of actions, m course of action, choosing the first course of actions with the probability P1, second choosing the course of actions probability is P2. So mth course of action that player A chooses with the probability Pn. Since it is a probabilistic method, the sum of the probability will be 1. Whose sum is unity, where each number represents the probability with which each course of actions is chosen. You can see Pi is the probability of choosing the ith course of the action. Then S we can say P1, P2, P3, Pn. This is the set of the probabilities, that is respectively they are choosing the course of actions 1, 2, 3, 4 up to m. So we can write in the summation notation I is equal to 1 to m, Pi is equal to 1, where Pi greater than equal to 0. Some Pi's may be 0 and some maybe have the fraction value. If it is the completely pure strategy, all will be 0 except 1 will be 1. I is equal to 1 to m. In fact, a pure strategy is a special case of the mixed strategy. A pure strategy is a special case of the mixed strategy in which all but one Pi are 0. One Pi are not equal to 0 and all are the 0, so that a player may be able to choose only impure strategies. That means when mixed strategy becomes a pure strategy, when all others the probabilities are 0 except 1, that will be the value is 1. That is, it is come to the pure strategy. Back to the pure strategy. But one Pi are 0, so that a player may be able to choose only m pure strategies, but he has an infinite number of the mixed strategies to choose from. That infinite number combination, it is too much difficult to solve the problem. So to solve the problem, that is some rules is there, we will learn that rules. Optimal strategy. The course of actions of each player is to choose a strategy or a set of strategies for which each payoff after the game maximize the profit of a player or minimize his loss is called the optimum strategy. That means choosing the course of actions by the player in such a way that one player's after the end of the game, one player's gain is the maximum gain, another player's loss is the minimum loss. In this situation, it is called the optimum strategy. With respect to those strategies, we are getting the for a player maximum gain and another player is the minimum loss. That respective strategies are known as the optimal strategy. Payoff. It is the outcomes of a game. Let player A have M course of action and player B have N course of action, then the game can be described by a pair of matrices which can be constructed by the following rules. Payoff, it is the outcomes of the game. That means from the game, what are the rules is defined, that payoff, what is B have to pay A, that is the payoff gained by the A, and another is payoff paid by A to B, that is with the negative entry. That is seen in the first slide with an example. Then the game can be described by a pair of matrices which can be constructed by the following rules. Row designations for each matrix are the course of actions available to player A. If it is related to the player A, then it is the matrices for the player A. Column designations for each matrix are the course of action available to the player B. The cell entry Aij is the payment to A in A's payoff matrix when A chooses the course of actions the ith and B chooses the course of actions the j. That means Aij is the payoff corresponding to the ith course of action chosen by the player A, and jth course of action chosen by the player B. In this case, Aij is positive and B have to pay to A, and A is positive. In a 2% zero-sum game, the cell entries in the B's payoff will be the negative of the corresponding cell entries in A's payoff matrix. A is called the maximizing player as he would try to maximize the gain, while the B is called the minimizing player as he always would try to minimize his loss. This is the A's payoff matrix. This is A's payoff matrix. A11, A12, like that. This is the payoff. Each and every element is known as the payoff, and this matrix is known as the payoff matrix. This is the A's payoff matrix. All the elements are the positive. That means B have to pay to A in the course of action, any course of actions. And this is all the elements with the negative sign. That means this is the B's payoff matrix. That means A have to pay to the player B. Note that the sum of payoff matrix of A and B is a null matrix. If we sum up these two matrices, what we will get? If we sum up these two matrices, we will get the null matrix. Note that the sum of the payoff matrices A and B is a null matrix. Here the objective is to determine the optimal strategies of both the players that result in optimum payoff to each, irrespective of the strategies used other. Now the optimal strategy. We already learned the optimal strategy, but we are describing here in other way. This strategy that puts the player in the most perfect preferred position, irrespective of the strategy of this opponent, is called an optimal strategy. On the other hand, we can say the course of actions which maximize the profit of one player, and on the other hand, minimize the loss of one player is called the optimal strategy. So by selecting those strategies, maximizing player maximize his gain and minimizing player minimize his loss, that is our optimal strategy. Games of perfect and imperfect information. If the strategy of a player can be discovered by his competitor, then it is known as a perfect information game. In case of imperfect information game, no player has complete information and tries to guess the real situation.